Alrighty, 56. How many distinct line segments exist in the figure? Distinct means not naming the same one multiple times, not being like VW and then WV, because that's not distinct. That would be the same segment twice. So let's find all the distinct ones. Let's start by all the segments that start at V. Well, there's VW, that's one. There's VX, that's two. There's VY and VZ, that's 3 and 4. Cool. Let's so we named all the segments that start with V. Let's name all the segments that start with W. Well, there's WX, there's WY, that's 2 of them. And there's WZ, that's 3. So 1, 2, 3. So far I'm up to 7 segments total. Let's name all the segments that start with point X. So there's XY, and there's XZ. That's only 2 of them. That's all I got. 1, 2. And then lastly, we can name all the segments that start with a Y. And you got YZ. And that's it. So I can't be like YV because we've already named YV a long time ago when we named all the segments that started with V. So we got 10 total segments. They're distinct is the magic word. Number 57 is a fun question. What is the slope of the line parallel? That should mean something to you. It should mean that the lines have the same slope. So what is the line slope of the line that's parallel to the given line? Now, the reason this is like a question that requires a little bit of work here is because this is in standard form, and I don't like standard form. Nobody likes standard form. Standard form is anything that's written like ax plus by equals c, and that is not cool at all. We like y equals mx plus b. That's cool. So what we're gonna have to do is move some of the variables around. Alright, a little something like that, and then, you know, we got y, okay, and then divide by b. So we're gonna have to move some stuff around. That was weird, but we're gonna move some stuff around to make it look like y equals mx plus b. The first thing I'm gonna do is move those 3 x's to the other side of the equation, because in y equals mx plus b, the x's and y's are on different sides of the equation. Alright, so now I have a negative 2y. It almost looks like that, but I don't want any numbers in front of my y, okay? So no numbers in front of y. That means I'll have to divide by that negative 2. So that's going to give me y equals negative 3, negative 2 makes a positive 3 halves, and negative 6. Now all we wanted was the slope. Remember, y equals mx plus b. The b is what, the m is what represents the slope. So that's the only part I care about, is the m part of the equation. And that's 3 halves. So because the slope of this guy is 3 halves, then the slope of a line parallel to that would also have a slope of 3 halves. What? This is almost the same question as the previous one. So we'd have to do the same thing, but you notice it's like the same equation too. So I'm going to do it just to be like a good teacher. Move the x's over. Divide by negative 2. So this one is slightly different because it says perpendicular, so that has to mean something real special to you. Perpendicular lines don't have the same slope. They have opposite reciprocal slope. So that means we got to change the sign and we got to flip it. So if our slope was 3 halves, we got to change the sign. So it's going to become negative because it was positive. And instead of 3 halves, it's going to become 2/3. That would be the slope of a line that is perpendicular to this one. So negative 2/3 is the slope for me. Alrighty, angles A and D are not. Are not what? Adjacent. Adjacent means next to. And A and D are next to each other. So they are that. They are not supplementary. Well, supplementary means that they add up to 180 degrees, and A and D totally add up to 180 degrees. So they are that. Complementary. I don't think they're complementary. That means equals 90. So it wouldn't make sense for them to be able to equal 180 and equal 90. That doesn't make any sense. So C is what they do not do. They're not complementary. D says a linear pair. Well, linear pair is a combination of A and B, adjacent and supplementary, so they do that. So the correct answer is C. A and D are not complementary angles. Complementary angles would be like, here's A, here's D. Those would be, excuse me, wow. Those would be complementary because they add up to 90 degrees. All right, question number 60 says B and D, all right, angle B, angle D are not, oh no, are, wow. Complementary, they don't look complementary, so put an X on that one. Supplementary, they don't look supplementary. Let's put an X on that one. Adjacent, they don't look next to each other. Put an X on that one. Vertical, they are vertical angles. They're those opposite angles formed by the intersecting lines, and they're congruent to each other, so D is what they are. All right, 61 through 64, use the diagram to identify the relationships. Angles A and H. Here's angle A, here's angle H. They're both exterior. Exterior means on the outside of the parallel lines, and they're on opposite sides of the transversal. So A and H are what we call alternate exterior. Alrighty, A and E. A and E. Where's A and E? Angle A and angle E. Alright, so with angle A and E, one's exterior, one's interior. Alright, that's usually a good hint that they're going to be corresponding angles. They are corresponding angles. The reason I know this is they're both in like the same spots, but for the different groups. Angle A is in the top left of its group. Angle E is in the top left of its group. So we call those corresponding angles. Up next, we got angle D and angle F. Angle D and angle F. All right, those are both interior angles. Interior. And because they're on the same side of the transversal, which is the green line that we got going on right here, the line that intersects the two other lines. So D and F would be same side interiors, also known as consecutive interiors. And 64 talks about C and F. All right, all right, all right. Angle C and angle F. Angle C and angle F. Angle C and angle F. Interior angles again, but this time they're on opposite sides of the transversal, so we call those C alternate interiors.